forgot to record. Okay. So now you could take a dot product to find the angle between the momentum vector and force vector. And if you take the dot, you will get sine kt into cos kt and minus sine kt cos kt, which will cancel out. And the answer will be 0. I mean 90 degrees. So f dot p, if you do, you will get the 0 answer, which means the force vector is actually perpendicular to momentum vector, and therefore the answer is 90 degrees. Okay, so answer is D option, 90. So don't worry, I haven't taught you differentiation. So the only way we can solve is by waiting till you learn the differentiation. Any other question? Siddharth?
No, sir. That's it.
All right. Anybody else who has solved this part, the vector part? See, guys, if you're not doing the homework, then it's very difficult for me. Then you have to sit with me for 5 to 6 hours. You will get it done. So choice is yours. I will not leave, for the not doing the question. I expect that everyone is solving at home. Okay. So how much you solved, Siddhant, up to like completely?
No, sir. I've done around 67 questions.
Okay, that's right. Okay. What happened to you, Tanish? You are getting
Yes, sir.
locked out?
Internet connection unstable.
Okay. So you can do one thing. Whenever the Wi-Fi is unstable, you can log in from the phone. The hotspot is more stable than sometime internet.
Yes, sir. Actually, the hotspot is not also giving me the internet connection. That's the issue.
Okay. No problem.
Some error
Anyway,
probably.
yeah, it is getting recorded. In case if something goes, you can watch it again. Okay. So today we have to start or we have to finish something. The dot is done. The cross we have started now. So yeah. So we have started the cross product, and we saw the definition of cross product, and the A cross B, the way it was defined was mod of A, mod of B, sine of angle between them into the direction which is normal to the plane containing the vectors A and B. And to learn the same, we applied the right hand screw rule, or like the Fleming right hand thumb rule, and so on. So in that, I think there should not be any difficulty. The definition part. I think there is no difficulty in things are defined. And the matrice, okay, the determinant form of the cross product we have seen. That how to express it. So given A as AX I cap, AY J cap, and AZ K cap, and B vector as BX I cap, BY J cap, and BZ K cap. If you write A cross B, the order is very important, as I said. So you can rewrite in the determinant form by writing the first row as IJK, because it is A cross B, so the elements of A will come first, and then comes the element of the B, and then there is something called the expansion along the row or a column. So you can expand this entire determinant in this direction, and you protect this as plus, minus sign, and plus sign. Okay, so A cross B you can get using the determinant. We have done some problem, so we'll do today some more problem in physics. In fact, I will teach you those basic ideas of physics in which cross is thoroughly used. Okay. So we have something called a relation between angular velocity and linear velocity. I mean, of course, it's a big topic. So let's say if we have a circle, and this is, let's say, some axis, and this circle is a part of some big board. Okay. Anyway. So now this is a body actually, which is so this body is spinning around its own axis. So omega is called the spin axis. And because it is spinning about the axis, if you draw any circle which is having the plane normal to the axis, you can easily find the velocity of any point P. And to find the velocity, there are some unsaid rules which you are not aware of. So the rule is simple. So to find the angular velocity, you can choose any point on the axis. You can choose any random point. And then you can join the point, random point which you have taken to the point P. So you just join it. And then you can call this vector as R vector. And the omega having this direction. So omega vector you can say is upward. R vector is the position vector of the point P whose velocity you want to find. So the entire body is spinning. So can we say every point will have some velocity, yes or no?
Yes.
And because every point will have some velocity, so there should be a way to find it. And the answer is pretty simple. You just choose a random point on the axis, join with the point whose velocity you are trying to determine. And then the velocity of the point P we can write as omega cross R vector. Now, why this answer has nothing to do with the origin taken? The reason is simple. We actually need this distance, right? D. Okay. We need this distance because we know from circular motion that The velocity is simply omega into d. But d is not given to you. So if I choose this angle as theta, can we write d as r sin theta? Can we say, guys, that d is r sin theta?
Yes, sir.
And therefore the velocity of the point P will become omega into r into sin theta. And this is like a cross product omega cross r. You may say that's why not r cross omega. Now we know if it is turning this way, the point P will go inside like this at this instant, right? So the direction is into the plane at the point P. And if you do the omega cross r, you can see the direction is into the plane, right? If you do r cross omega, it will give you out of the plane. Do you realize this? So try the omega cross r using the right hand. Omega is up, r is towards the right. Omega cross r. Thumb is inside. Can you see? The thumb is pointing inside.
Yes, sir.
So the omega cross r will give you the velocity. And that is why the answer has nothing to do with the origin taken, because eventually the r and theta, what we call r sin theta, eventually becomes d value. So it will give you the same answer. The detailed form is like this, which I will teach you anyway in circular motion. It's too deep as of now, so I will not go into it. Similarly, we have something called angular momentum. And we have a symbol for it. We write as L vector. So let's say if we have a particle, I'm not saying a body, a particle. So if we have a random particle which is moving on this line, and let's say the particle is moving with a velocity v, and the particle is having mass m. So we are aware of something called momentum. And how we write momentum, guys? Anybody? So for
Mass
momentum, we
into
use the
velocity.
mass into velocity. Very good. So momentum is a vector quantity which is written as product of mass into velocity, which is like the scalar multiplication of velocity with mass, right? We have done this before. So mass will scale the velocity, right? It's like a scaling value. Now let's say we would like to know the angular momentum of this particle with respect to some origin O. Origin is somewhere randomly in the space. So first thing that we do is we drop a perpendicular from the origin to the line. You can call the distance or the perpendicular as d. And if you join the particle to the point O, then this is called r vector. Okay. So this is the direction of r vector. If I call the angle between velocity vector and the r vector as theta, so the definition of angular momentum of this particle with respect to O is given by r cross p vector. This is how we write the angular momentum of a particle. This is the formula, r cross p. And again, what about the r cross p? If you take the modulus, it is rp sin theta, correct? And if you look carefully, what is r sin theta representing? So what is r theta representing? Can you see what is r theta representing here? Anybody? In this triangle, the r sin theta is representing
30.
the perpendicular separation. So you can see L equals to PD. The momentum into the separation between the line of motion. There is a term for this. In physics, we call line of motion. And D is called the distance between the point and the line. Okay, so for every point and a line, the distance we express in terms of the minimum separation or the perpendicular. That's the whole idea. So if you know the separation, the product will give you the angular momentum. And what is also interesting to know here, that no matter where the particle is, as long as the line of motion is maintained, can we say the angular momentum is maintained or constant? So if you keep on moving on the same line, the D will remain same or change?
Remain same.
Yeah, so that's the whole idea. So the angular momentum, you will learn, of course, these things in rotational dynamics, but as a basic idea, you should know that the angular momentum remains constant even though you move away and away. So even though the R will change, the cross product will never change. Okay. And that's very interesting. So we'll of course come to that later on. Okay. The other way of thinking is, let me teach you a bit of rotational dynamics. If I resolve the velocity into two directions, one parallel to r vector and other perpendicular to r vector. What is the parallel to r vector? Can we say this is v cos theta? And if you resolve the velocity perpendicular to r, can we say this as v sin theta? Yes or no, guys? Tell me.
Sir.
Can we say v sin theta? Now you tell me, for this particular observer, if this is some sort of observer looking at the particle, so which component of velocity will give the angular effect or turning effect? The sine or the cos? Can you feel the turning effect? Out of these two components, which component you think will give the turning effect, guys? V cos theta or V sin theta? V cos or V sin? Tell me. Hello, hello. Am I audible, guys?
Yes, sir.
Am I audible to everyone?
Yes, sir.
Yes, sir.
So now tell me, we have V cos theta. See, O is the observer and looking at the particle. Now V cos theta is parallel to R vector and V sin theta is normal or perpendicular to the R vector. My question was, which component will give the turning rotational effect to the observer?
V
The
sin.
sine or
V
the
sin
cos?
theta.
V sin theta. Very good. So the angular momentum, we can also think this way, that it is the momentum multiplied by the distance, which gives the angular effect. You can also think like mv sin theta into the, and for this line of motion, the r is the perpendicular distance. You can think this way also. So if you take the product, you will get the same answer. And why the angular momentum is I'm teaching here, because the very first chapter that you will study in chemistry called atomic structure, And in that atomic structure, you will have an electron orbiting the nucleus. And there you will learn about, there you have to use the concept of angular momentum. That is going to be the second, I think the postulate of Bohr's atom. That is the quantization of angular momentum. We'll come to that. So you should have the basic idea of angular momentum even now. So how to find the angular momentum? It's very simple. For the given observer, just check the velocity component which is giving you the rotational effect and multiply that component of momentum with the distance. That's fair enough. Or you look at the line of motion and multiply the momentum, the actual momentum, with the perpendicular separation of the line of motion and the observer. So these are two ways of thinking. See, this is the angular momentum, momentum which is creating the angular effect multiplied by r. Or if you look here, the momentum actual multiplied by the d. Both are same. So these are two interpretations. So I'll give you the idea of circular motion. So imagine there is a particle called electron. And this electron is orbiting around this circle. So this is again a question of a particle moving. So if you look at any instant, let's say at any instant the electron is here. So the velocity direction will be tangent to the circle, right guys? Can we say like this?
Yes.
And because you are moving in a circle, your velocity is like this. This is v vector. And if I choose the axis as the, or O as the origin, the r vector is going to be like this. Now tell me guys, what is the angle between the r vector and the momentum vector? Can you see the angle? Anybody? What is this angle?
90 degrees.
Is 90 degrees because that's a property of a circle. In any circle, the tangent is always perpendicular to the radius. So this property you all studied in class 9th or 10th, which is very useful even in 12th. That's interesting part. So it is not like that what you studied is of no use. It is of great use. So in circle, the radius and the tangent are always mutually perpendicular. So you can see the momentum and the r are by default perpendicular, correct? So what will be the angular momentum of the electron about O, guys? Tell me, if it is the mass of electron, if the r is the radius, what is the value of angular momentum? Can you tell me from the diagram? What should I write?
MVR.
MVR. Very good. So for any particle moving in a circle, the angular momentum is momentum into perpendicular separation from the O, which is obviously here R. And if you multiply these two, you will get the answer. Is this clear, guys? How to get the angular momentum of a particle?
Yes, sir.
Now, there is something called angular momentum of a body, which you study in rotational dynamics, not now. So now this part is not required. Only rotational dynamics, we talk about something called angular momentum of a body, which is slightly difficult concept. Not difficult, means like, involved, something more involved. So these are the some application of cross product. And of course, this is the giving you a very much mechanical way of writing the same thing. Like if you don't even understand the rotational dynamics or rotational motion, then you can use that definition to get the answer. L equals to R cross P vector. And then the definition is A, B sin theta, N cap. And you can take the modulus and you can say it's A, B sin theta. Then here theta turns out to be 90 for the situation discussed on the right. And we have the MVR as answer. Okay. So do remember this MVR is going to be very, very helpful to you. Very soon in chemistry, you have to use it in the chapter called atomic structure. Okay. Okay. So another use of cross product. So I'll do this next one more. So when a force acts on a body, it is capable of creating some turning effect. It may create, it may not create if it is balanced by some other force which we don't see. But a force is generally capable of creating the angular effect, and the measurement of that effect we called torque. So when I say torque, which is a very common term which you see in the specification of car. If you go to any app which sells car, and if you read the specification of the car, the technical specification, they mention something called torque. And how we measure Nm. The Nm represents Newton meter. So when your car is in the low gear, so the first gear is a gear in which the car produces maximum torque. And in the fourth onwards, so you may have the 5-gear car, it may have 6-gear car, and it may go up to I think 7. If you go for Ferrari and all, they have 7 or 8 gear maybe. But any high-end car will have 5th gear, but nowadays 6th gear is also very common. So let's say I will go up to 4th gear. So as you increase the gear number in a car, it goes to the lower torque value. So generally we need more torque when we are trying to climb some slope. So while going into the hilly areas, the car is generally kept in the first gear or second gear because you need a lot of torque to climb the slope against the gravity. On a flat highway at a very high speed, if you're driving, the car will have inertia to continue its motion. The air resistance will decrease the motion a bit, and therefore to maintain the air resistance effect, you need to have some gear. So we put in the 5th gear because I need the bare minimum torque actually. And in 5th gear, or you can say gear in the highest possible gear in a car, the car is in the least control mode because the lesser gear means the engagement of the gear system is very much less. You may be not in a very good control. Okay. So nowadays, the high-end car will develop some extra stability mechanism using some other methods. So they have their mechanism properly in place. And as the car cost becomes more and more, the first change you will see is the torque value. Okay. So of course, the expensive cars are so powerful they can climb almost vertical hilly area. And if the car is, let's say, a small car, it will have some difficulty in moving almost vertical slope. So you cannot move very vertical. I mean, of course, slightly vertical is okay. Too much slope is very difficult to maneuver. So torque is a very, essential concept in every vehicle. The torque is the backbone to start the motion, to turn the wheel, and the car is only capable of creating the torque. It is the friction on the ground which enables the car to move forward. So with engine, we don't move the car. With engine, we turn the wheel. But when the wheel is trying to turn on the road will apply the friction force, and that friction will help you in moving forward. That's the whole idea of car and friction. So no matter how expensive the car is, it cannot move forward without friction. Okay. So with a greater torque, you are able to turn the wheel more rapidly, and then you achieve the desired effect. So now let's say if we do the simplistic view, that's called the lever arm, the first order machine. So this is the torque is also called the, I mean, we have something called lever arm, which is called the first order machine. You might have studied this first order machine if your board was ICSC. In other board, it's not there, right? Anyone from ICSC board?
Yes.
Oh. So the first order machine, so we'll learn that. So let's say we have a rod. Let's say we have a rod. And this rod is somewhat a hinged rod. So hinge means we put some sort of a hole, and across the hole we put some thin iron bar, something about which you can turn around. So this is like a hinge. So let's call the hinge as O point, the origin. And the next thing is at the other end of the rod, the other end, not that side. So near the other end, we apply some force F. At an angle theta. Again, we can always do the same resolution of force. So the force we can resolve into two components, F cos theta, the projection of force along this line, and the other will be so this component, what we can write, guys? F sine theta, right?
Yeah.
The resolution of vector is clear, yes or no? Because that's very important. Okay. And the point where you apply the force is called point P, and we call it point of application of force. Point of application. And this distance, the O to P, this is called R vector. So O to P we call R vector. Okay. So this is the OP vector. Now again, I'll ask the same question. Out of these two components, tell me which component can create the turning effect or will turn the rod about O.
Sir, F sin theta.
And that's very much intuitive. I mean, we can understand clearly that F sin theta is capable of creating the turning effect or a rotational effect. And whereas F cos theta will do nothing. Okay. So the torque of a force about a point O is that component of force which can create the turning effect multiplied by the perpendicular separation from the O, which is R. It's the same logic. You can see in the cross product, the logic remains same across the physics. I mean, no matter which definition you pick, you will realize that there is a single method of getting the answer. And the product of these two terms will give you the magnitude of torque. And this you can write as RF sine theta. This is one way of thinking. The other perspective is what? Don't resolve the force. Keep it the way it is. But extend the line of action. So we have something very interesting term. It's called line of action. You might be thinking I'm saying light, camera, and action, but it's a line of action. So the line of action of force. So if you are looking at O point, then how far is the point O from the line of action of force? Can you find the distance of the O from the line of action? So what you will do, you will drop a perpendicular. And this is also theta, as you can see. So this is called D. And how much is with the value of D, guys? What is D? Tell me.
F sin theta.
No, D in terms of R, no? How to express D in terms of R?
Yeah.
It will be R sin theta.
Yeah.
Yes, sir.
So the other way of thinking is that torque is force into that distance about which the force is perpendicular, which is D, FD. The fixed deposit. Oh, my bad. So FD, and again D is nothing but R sin theta. So these are two perspectives of thinking, that you multiply the component of force which is creating the effect about O. So if we have observed so far, you will see there is a pattern. And the pattern is either you resolve the vector normal to R and parallel to R and multiply the normal component with R, or you resolve the R normal to the other vector and parallel to the other vector and then multiply the normal component. So it's a same thing throughout we have been doing. So in every definition, R is common and either R cross something came here or something cross R we saw so far. So every definition that we have seen so far will have this format. R cross something vector or something vector cross R, because the first definition was unique. The first is very unique because here the omega comes first and R comes second. Omega cross R. Only in the velocity relation, the omega comes first, R comes second, but in other relation like angular momentum, the R will come first. In torque also, the R will come first. So the vector notation of torque is R F sin theta, which is R cross F. Okay. So the cross product will give you the torque value, and if you go from R to F, I hope you can see the R vector direction. So R vector is this way, and the F vector was this way. So if you go from R to F, how the rotation will take place, guys? Clockwise or anti-clockwise? If turn R to F, the rotation will be clockwise or anti-clockwise? Tell me.
Anti-clockwise.
And if it is anti-clockwise, then using the right hand tool, if I think that R and F is in the blackboard plane, so what will be the direction of R cross F? Normal to the blackboard?
Yeah.
So towards us or away from us? What is the direction? Towards us or away from us?
So towards us.
Very good. So if you turn from R to F, you can see the effect will be towards us. So direction of torque gives you the axis about which the turning effect will be produced. The direction of torque is not the direction in which the body will turn. These are called axial vectors. Okay, so a vector which is defined by cross product are generally axial vectors, not always. So the property of axial vector is they don't have the beginning or the end. They have only sense of direction. Okay, so they are having no beginning and there is no end. So the torque will not have a origin. Torque will have only the sense of direction. So the direction of torque represents the axis actually. The axis about which the body will turn eventually. So that's the meaning of torque. Okay. So because we write torque as R cross F, we can also write this in determinant form. So I, J, K will always come first. The R vector we can write first as something X component, Y and Z component. And the F vector we can write as Fx component and Fy component and Fz component. And that is how we calculate the torque value. Okay. So if we can define the R vector and if we can define the F vector, we can define the torque. So let's do one example. Okay. So let's say there's a point O in space. There's a point P. So O is the origin. Let's say the coordinate of O is 0, 0, 0. The point P is the point of application of force that I will draw later on, having coordinate 3, 2, 1. And at this particular point, a force is acting, and the force is given by the formula I cap plus J cap minus 3K cap. Just like this, some random direction. So what is the torque produced by the force about O? You can solve this question. Easy enough.
Yeah.
So please go ahead and tell me the answer. Everyone.
Yes, sir, got it.
Got it, sir.
So how much are you getting the answer? What is the answer in terms of I, J, and K?
minus 7i plus 10j plus k.
Just take it.
Is this the answer?
Yeah.
I hope everyone is getting the answer. So let's do the example number 2. So now we don't have the origin. I mean, you can choose origin. I have a point A with some coordinate 1, 2, 1, and the B as 3, 1, minus 1. And the force is acting as minus I plus J plus 2. Now I want to know the torque about A point for the same given force F. Now, if I say that find the torque about A, then A becomes your origin. That's the whole idea. And the R vector will be always from the origin to the point of application. Now, here the B is the point of application that you need to understand. So this is your O, this is your P. The R vector now becomes OP vector, which you can determine. You know how to find OP vector? I hope so.
Yes, sir.
Yeah. So now you can do the rest. So at the end of the day, the answer is OP cross F. So it is not necessary that always you will have the origin and the point. You can create your own origin.
So I think I have the answer.
Okay.
It's 2j cap plus k cap minus 2j. Yeah.
Okay, that's it. Only KK?
I is coming out to be 0.
Yeah, maybe possible. That's quite possible. So anybody else, please confirm the same.
Yes, sir.
Yes, sir.
Very good. So you got the answer. So we have seen some definition in the last lecture. We saw uh, today some definition in physics. One particular cross product application which I'm always interested in, and there is a reason for it, because you won't get a many opportunity to study again and again in physics. It's very less used, but it is very important. And this is called Poynting vector with unique symbol S. And the Poynting vector is basically a vector which is meant for representing flow of energy, the electromagnetic energy through space over a uniform unit cross-section area per time. So by definition, it is the energy, uh, electromagnetic energy flowing through space over uh, over a unit cross section area per unit time. For example, if sun is the source of light, so basically sun is the source of the entire electromagnetic energy, and the energy travels from sun to earth, and we receive a very tiny fraction of that energy, but that is too much to create the extreme summer, and the absence creates extreme winter. So we are quite a lot depending on the sun's energy for our own survival. Apart from the plasma at the core of Earth is trying to keep the Earth warm enough to let the creature survive. Anyway, so the idea of Pointing vector is that what is electromagnetic wave? So what you call light is basically an electromagnetic wave in which the axis of oscillation of electric field and the magnetic field, these two fields are mutually perpendicular. So the electric field will oscillate like this. Which means this is the oscillation. So this is the plane in which the electric field will oscillate, and the magnetic field will oscillate in a totally different plane. And this oscillation continues forever. So it is not going to stop. And in this way, the energy of the light propagates in this direction. This is called the direction of speed of light. I mean, the propagation of light. And you can see something interesting, that E vector and B vector together creating the energy propagation in a direction which is perpendicular to E as well as B. So can we say the propagation is determined by the cross product of E and B? Can we say yes or no?
Yes, sir.
Anybody realize the last lecture that the E and B coming together is creating an effect which is neither along E nor along, I mean, neither B along E or B nor along B, and rather it is moving in the direction which is normal to the plane of E and B, right?
Yes, sir.
So this is the classic case of cross product, because something like this, if you see in nature, you should have the sense that, okay, this has to do with something with the cross product, because only such effects are meant in cross product. So the definition of Pointing vector is written by the symbol 1 by mu naught. Don't worry about all this terminology. And we write E cross. So E cross B is called the propagation direction. So this gives the direction of propagation of EM wave. It may be light also, but light is only a small part of EM wave. So this is the very interesting pointing vector, and I just wanted to introduce this term. You will study at the end of the class 12th syllabus called EM wave, where I will re-invoke the same to explain something more deeper of science. So now I would like to know that what is the geometrical significance of cross product. We have seen the geometrical significance of dot. So it would be unfair if I don't discuss the geometrical interpretation. The geometrical meaning of cross product. Geometrical meaning of cross product. So we know that if A and B are two vectors, and if we draw the A and B as the two adjacent sides of a parallelogram, so the rest part we can complete by so you can draw two vectors parallel to each other, like parallel to B and parallel to A respectively. And this forms our parallelogram, okay? So if the angle between the vectors A and B is theta, okay? So what is the A cross B value? A cross B. So by definition it was AB sin theta, n cap. And an n cap will be towards us because I'm considering A and B into this plane, the blackboard. Okay, so we'll right now focus on A cross B itself. And that will be only AB sin theta. The n cap becomes 1. Okay. Now, if you look this as only parallelogram, don't see this as a vector center, only parallelogram. Let me draw it separately. So how to find the area of a parallelogram? Maybe it's difficult. So you can join the diagonal. Now you know the area of a triangle, right? Anybody who can tell me the answer?
Half base into height.
Half base into height. Very good. Okay. And can you prove the formula why area of triangle is half base into height?
We could try using Heron's formula.
That's too much. Not that much. You can just think. Every formula in area which you study or you will study throughout your life, there is only one formula in physics, mathematics, and that is area of rectangle, length into width. That's more than enough. And every other formula I can derive from there. Let me show you something interesting. This is the very basic of area. So you can clearly see that this area is same as this area. right?
Yes.
And this area is same as this area, correct? And therefore, the total area of the bigger rectangle is how much? A into H, right?
Yeah.
A is the entire base, H is the height, so the width is H. So the entire area is A into H. And can we say the area of the triangle is half of the rectangle area because it's a same portion is here and same portion is here?
Yeah.
Okay. We know the only formula for rectangle, and from there we can get the triangle. You can think always like this. Anyway, now because we know the area of triangle is half into base into height, so finding the height will is sufficient to get the answer, right? H is not given here. What is given here? A and B. So can we calculate H? That's the question.
Yeah.
What is H here?
So in terms of theta or using the Pythagoras
Yeah,
theorem?
no, of course, in terms of the given parameters, A and B and theta.
The B sine theta.
Very good. So can I replace this as B sine theta? The area of triangle is half AH, which is half AB sine theta. Okay. But AB sine theta is what?
A cross B.
It is mod of A cross B.
Yeah.
Just a moment. So similarly, the area of a parallelogram is how much? Isn't it just twice the area of triangle? Can I say the area is just double the area of triangle? Tell me guys, yes or no?
Yeah.
So can we say it is exactly A cross B? So the A cross B is actually giving you area of a plane surface or area of a parallelogram in which the A and B are the two adjacent sides. So two vectors we are taking as the two adjacent sides of a parallelogram, and by writing the cross product is giving us the area. And this is like blessing in disguise, isn't it? It will unleash a lot of mathematical formula to be derived very easily and very conveniently. Okay. Do you agree? Yes or no? Maybe.
Yes.
Okay. So geometrically, what it represents? The area of a parallelogram. So now I'll put it here. So now I hope you have realized why area is called vector. Okay. So geometrically, A cross B represents area of a parallelogram with A and B as its two adjacent sides. So it is the magnitude of area. If you want to write in vector form, you can simply say area vector. I can say area vector For a parallelogram, we can only write A cross B. Or you can also write B cross A, so we can write plus minus because it really doesn't matter which side. So for a plane surface, I can write A cross B, I can write B cross A, it really doesn't matter. Okay. So the area is clear. And in the entire physics, in the entire mathematics, the only single area which one should remember is, and that is called the area of rectangle. You may be wondering that say how we can find the area of rectangle. Area of rectangle is so powerful, it can give you the area of circle also. So using the area of rectangle, you can find the area of circle. Using the rectangle, you can find the area of surface area of cone. Using the rectangle, you can find the surface area of sphere. So rectangle is the only area which one should know. Nothing is required in mathematics. And if you understand the concept of area, you're done with half of physics. Because in entire physics, the only difficulty you will face is the area and the volume. So what is the definition of volume? What is the volume of cylinder? So what is the volume of cylinder? Tell me. Anybody? Hello, hello, hello. Am I audible?
Formula.
Formula.
Pi r square h.
Pi r square h.
Excellent. So everyone knows the volume formula is pi r square h. So what h represents?
Height. Height of the cylinder.
This is my cylinder. I think cylinder is feeling offended because I have done something like this. Okay, nevertheless, this is my cylinder, and the L is the slant length, and this is my. Why I will say this? So what is the volume now? Tell me, guys, what is the volume?
Pi r square L.
Sin theta.
Pi r square L sin theta. Very good. Imagine if you have a packet of some biscuit. Maybe which biscuit comes in a round shape? Oreo. Yeah. So you can open the packet and then tilt the topmost biscuit like so slightly ahead. So by moving it slightly ahead, slightly, the shape becomes like this. So volume depends on which height. We call the vertical height. And what is vertical height? The separation between the cross section, the top and the bottom. So what really matters is this height, not the L, for volume calculation. Okay. Okay, what is the curved surface area of cylinder? Anybody?
So right circular cylinder is 2 pi RL.
So the curved surface area of cylinder is, the right circular cylinder is 2 pi RH. So what we can write here, 2 pi RH or 2 pi RL?
So 2 pi r L.
So here we should take the slant length or the vertical length.
The slant length.
Slant length. Yeah. But while finding the volume, what we took?
Vertical length.
and that is the basis of the volume and area calculation. In area, we take the slant length, but in volume calculation, we only take the vertical length, and that is the basis of entire integration concept in physics, that we are going to use very often. Okay. Anyway, so we'll come to those things later on. In maths lecture when we will start after this chapter. So there are only few fundamental definitions in mathematics. The rest are derived actually. So there is no other area formula except the rectangle. Okay. And basically the way to remember the formula of volume is area of cross section into vertical height. That's the definition of any volume. But for this formula to be true, the only constraint is the cross section must remain same. And that is the beauty of cylinder. In cylinder, no matter where you go, the area remains same, isn't it? You can see here. Am I right? So if you draw any shape with constant cross-sectional area, the volume will follow this format or this formula. So what is the formula of volume? Area of the base into height. So if I have a cube, cuboid, let's say, if I have a cuboid, there are many ways I can write the volume. What is the area of this base? If I choose this as a base, what is the area?
AB.
And what is the height? C. But if I choose some other surface as the base, what is the area of the base AC? What is the height? B. Do you realize something? That no matter which side you take as a base, you can always see the cross-sectional view is maintained throughout. And therefore, the answer always turns out to be ABC, ABC, ABC. But what it is following the pattern? The pattern is called constant cross-sectional area pattern. So wherever we have the constant cross-sectional area object, the volume will have a similar definition. And therefore, the problem comes when the cross-sectional area starts varying actually. So let's say if I draw a cone. So what is the biggest problem with the cone? As you go from top to bottom, the cross-sectional area will increase. So can we apply the formula the way we have applied earlier? The cross-sectional area into height? No. And because this relation is the difficulty of writing the volume, so we bring something called concept of elementary volume. And what is that? Again, it's an entire topic of discussion in maths, which we are going to cover in detail. So what we do, it's like a kulfi, and what you do next is you cut a tiny piece of the cone. If you cut a very small piece, the piece is so thin, it's like paper thin. So can we think this as cylinder, the thinnest cylinder in the universe? Can you see this is thinnest cylinder?
Yes, sir.
And because it is a thinnest cylinder, can we say or believe that the cross-sectional area will not vary much while going from bottom to top? So if you move across this height, the thickness of the wafer, can we believe the cross-section is not changing here?
Yes.
We can believe. And because we can believe, so can we write the volume of this thin wafer? So it will follow which pattern of volume?
Area into vertical height.
Area into vertical height. So this is, let's say height, we will call it dy later on. So what is the volume here? Pi r square dy. Do you realize this? Yes or no?
Yeah.
And this we will call d volume. Okay, don't worry. All these things are concept of elementary, which I will teach you separately. What I'm trying to demonstrate here is the idea of concept of volume and surface area. In most of the case, we don't realize the basic definition of volume and surface area, and that's why we get confused why we are doing the way we are doing. Okay, so the whole idea was you must convert into thin piece. The piece is so thin that gives you the power to apply the definition of volume. So you cannot apply the definition for the entire cone, but you can apply for the thin piece of cone. Do you realize the power of definition? Why we cut elementary is having some predefined purpose. I mean, of course, the purpose should be understood. Anyway, so this we will explore in detail as we move in the maths part. So after after the concept of area, that the cross product is capable of, what is this? So what is the definition of cross product? We got the idea. It's a area of a parallelogram. And by dividing by 2, we can also get the area of a triangle, right? So it is very easy to find the area of a triangle and area of we can find the area of triangle and area of parallelogram, right? So the only difference is half, right? 1 by 2 and 1. So look at this. So the next concept is very famous and we must understand. In maths, this we call sine law. In physics, we have equivalent of sine law we call Lami's theorem. So we'll see both of them. So first we'll see through the lens of mathematics. If we have any random triangle, you can call it a scalene triangle. And if I call this as A, B, and C as the vertex, so we have some mathematical symbolic terminology. So the side opposite to the angle A is called small a. The side opposite to the angle B is called small b. And the side opposite to C is called small c. So we choose small alphabets to represent the length of the side of a triangle. And the bigger alphabet will represent the angle between the two sides. So this is called angle A. This we call angle B, and this we call angle C. For the sake of writing, we remove the angle sign, which simply call A, B, and C. Okay, that's only matter of convenience. So the cross product can give you a very interesting answer. So you can think this is a triangle. What is the area of triangle in terms of C, A, and B? Can we write half AC sine B? Can we say? Yes or no? I hope you're not getting it. We have done this before, na? Here. Area of triangle is what? AB sin theta. For this angle theta, can we say it is AB sin theta? Half AB sin theta?
Yeah.
Yes or no, guys? Tell me.
Yes,
Yes.
sir.
So if I choose these two as the side and the angle between them as the angle, you can express the area like this. half AC sin B.
Yes.
Yes.
But if I choose A and B as my side, can I write this as half AB sin C? Yes or
Yeah.
no?
Yes.
Yes, sir.
And can also be write as a half BC sin A.
Yes.
So from these three equations, can we say AC sin B is same as uh, BC sines of A B sin C, and this is BC sin A. Okay. So this is how you can express the equality. So these are the area formula, and then we can equate it, and therefore we can divide by ABC everywhere. So you can divide ABC here, here. And if you divide by ABC, you get something very, very interesting. What's the answer you're getting? Sin B by B, sin C by C, and sin A by A. I can invert it as well. So I can add A by sin A, B by sin B, C by sin C. And this relation, I think this is equals to 2R. R is called the radius of circumcircle, I think. I'll confirm this part. Radius of circumcircle. So what is circumcircle? A circle which passes through all the three vertices is called circumcircle. So this is called sine law in maths. You can even only remember this part. So any side upon the sine of the opposite angle is always constant in a triangle. Okay. And this leads to the idea of Lami's theorem also. So this is the first, the simple derivation using the concept of area. Okay, so let's come back to the Lami's part. Any doubt in the sine law, guys? Tell me. That's very important law in physics and maths both.
No,
No
sir.
doubt, sir.
No doubt.
Now, what is Lami's theorem? So it says in a different way. Let's say we have a body. And this body is acted upon by three forces. So if I call this angle as alpha, this angle as beta, and if I call this angle as gamma, so what is the alpha angle representing? Can we say alpha is the angle between these forces, F2 and F3? Because they are co-terminus vector. So can we say alpha is the angle between F2 and F3?
Yes, sir.
Yes or no? Can we say beta is the angle between F1 and F3? And gamma is the angle between F1 and F2? Can we say yes or no?
Yes, sir.
So alpha is angle between vectors F2 and F. So beta is what? So beta is the angle between which two vector, guys? Tell me.
F1 and
F1 and
F2, F3.
F3. Very good. And gamma?
F1 and
One
F2.
and F2.
F1 and F2. Very good. So imagine a body is acted upon by three forces, which you know in advance that it is acted upon by three forces. And body is at static equilibrium, which means it is at rest. So if body is at equilibrium, I'll mention static word. In fact, equilibrium is also okay. If the body is at static equilibrium, what does it mean?
Alpha is equal to beta is equal to gamma.
No, it means the net force is zero. That's the only meaning, right? Equilibrium means what? The net force is zero.
Yes, sir.
There is no resultant. That is the meaning of equilibrium. Okay. So F1 plus F2 plus F3 is a null vector. That's why it is at rest. So because if it is not at rest, it will move somewhere. It will have some acceleration action. Now, mathematically, when you have three vectors which add up to zero, so what it is representing? Okay, graphically, what it represents? A polygon with how many sides? Three sides. And because the sum is zero, it means this polygon must be a closed polygon.
Yes, sir. Exactly.
So what is the polygon of three sides? What we call?
Triangle.
Triangle, exactly. So whenever we have a situation like this, when three fourths add up to zero, graphically it represents a triangle. That is the whole idea. Okay. So we can say that the first vector, if I try to draw the first vector, I don't know about second vector. Let's say the second is something like this. And let's say the third one is something like this. And because the resultant is zero, so the third must meet the first. Otherwise, if there's a gap between the last and the first, it means some resultant is there, which is not the case here. So first of all, what you need to learn here is that how to represent the zero sum vector graphically. So I can call this as F1. I will call this as F2 and I'll call this as F3. Okay. The order doesn't matter. You can choose the order you want. Now, what is the angle between F1 and F2 vector? Can you tell me the angle? F1 and F2.
So gamma.
And what is the angle between 2 and 3?
Alpha.
So this angle we can call alpha, right? Because that is 2 and 3. You can see clearly. We have to make to find the angle between the vector, we have to make the either co-initial or co-terminus. So we need to extend the line. So how to represent the angle between F3 and F1? Like this. This is beta, right?
Beta.
So now eventually the mathematical or the condition in physics translates into eventually a triangle. And because it is a triangle, then sine law must be applicable, isn't it? So it may be, okay, we might have started from the vector, but Eventually, it's a triangle which is bound to follow the triangle law. So there are many ways to derive the relation, but anyway, I'll show you the cross product method. The area method we know how to do it. So we'll do something like this. So F1 plus F2 plus F3 equals to 0. We have all this relation. So I can write F1 plus F2 taking cross both sides with respect to F1. You know what does it mean is you write F1 cross the entire term both sides, but on the right side you use 0 only. F1 cross F1 will be how much, guys? Tell me. The cross product of same vector always gives 0. So F1 cross F1 will be 0. So that term is gone. So what we are left with F1 cross F2 plus F1 cross F3, which is 0. And I can put the second term on the right hand side of equal sign. A minus will appear, and then I will reverse the order of cross to make it plus again. So can we write this as, so can we write F1 cross F2 equals to F3 cross F1?
Yeah.
Now I took the cross with F1 to get this answer. If you take a cross with F2, you get another answer. So similarly, taking sorry, taking cross with F2 and equation 1 we have. I'll go to the next page. So what we can write F2 cross 1 plus 2 plus 3 plus nothing is null. So F2 cross F1, F2 cross F2 will be 0. So I will leave that part, and then last will be F2 cross F3. Now I'll keep the sequence in cyclic order. So 2, 3 is okay, fine, but 2, 1 is not fine. I'll shift this side and I will change the order. F2 cross F3 and F2 cross F1 will go on the other side, becomes minus F2 cross F1, which I can rewrite as F1 cross F2. Am I right, guys? Tell me.
Yes.
Sir.
So now we have sufficient term to compare. So I think call the question 3, and let's call this as 2. So 1 cross 2 is 3 cross 1, and 1 cross 2 is 2 cross 3. So can we say all 3 are equal? So from 2 and 3, can we say, guys, 1 cross 2 is 2 cross 3 is 3 cross 1? Yes or no? So that is the first proof that okay, the cyclic order of any two vector will be equal if you take the cross, because every term is representing, if I multiply by half, everywhere, then each term is representing area of a triangle formed by the vectors F1, F2, and F3. So I took a very different approach to get the same answer. So instead of taking the definition of area, we took the cross and we derived the answer. And this way of doing things is, I mean, you can say a good practice to solve mathematical problems. So when to take cross and just eliminate or vanish things as per your own wish. So now you can take modulus of the equation 4. So taking modulus of equation 4, you will get the answer F1, F2. I'm just writing. What is the angle between F1, F2, guys? Gamma. F2, F3. Tell me. Alpha, I think. 2 and 3 is alpha. Yeah. And the last is F3 and F1. I can attach beta. Okay. So, all right. So you got the answer. You can write, you can choose these two questions. So from 1 and 2, what you can write? Let's call it 1, 2. So take pairwise using 1 and 2. What you can write from 1 and 2? F2 gets cancelled. Tell me yes or no, guys.
Yes.
Yes, sir.
So F1 sin gamma equals to F3 sin alpha. So can I write F1 by sin alpha is same as F3 by sin gamma? Similarly, I'm not going to write next. So can I write eventually F1 by sin alpha is F2 by sin beta is F3 by sin gamma? Is it okay, guys, to write like this?
Yes, sir.
And this is called Lami's theorem. It is a very powerful method to solve many questions of static equilibrium. So whenever we have a question in which the body is at rest, and if we are able to figure it out that okay, the angles are okay, there are 3 vectors only, we can solve the question very easily. So I hope you remember the naughty problem, the problem in which we had some strings and block, right?
Yeah.
So long time back we did those questions. I'll just show you one of them. That how Lami's theorem can give the answer almost without doing anything. So a block is suspended, as you can see. A block is suspended from, you can see 3 strings. This is a knot. I hope you can see this knot. And this angle is, let's say, alpha. This angle is, let's say, beta. So at this knot, how many forces are acting? That's called T2, T1, and T3. Can we say T1, T2, T3 are in static equilibrium?
Yes, sir.
So if somehow we can find the angle between each pair of vector, we are done. Can we say this angle is alpha? This is beta? Yes or no?
Yep.
So what is this angle, guys? The angle between these two. Can we say it is pi minus alpha plus beta?
Yeah.
From the triangle.
Yes, sir.
And now what is the Lami's theorem? It says that T1 upon sine of angle between T2 and T3, like remaining 2. So what is the angle between the remaining 2, guys?
T2 and T3, it's 90 plus beta.
Very good. And T2 upon T2
So
upon
T3, 90 plus alpha, sine of 90 plus alpha.
and T3 upon
Sine of 180 minus alpha plus beta.
And from equilibrium of the block itself, you can say T3 is actually mg. So we can substitute the value of T3 because that's kind of known to us. Okay. And now you can see the answer. This T1 upon cos beta. So sin 90 plus theta is beta. T2 upon cos alpha. And this is mg upon, now this is something which you need to know, that sine of 180 minus any angle is the angle itself. And we are done, isn't it? So I can choose the first three to get the answer. T1 equals to how much? Mg cos beta by sine alpha plus beta. And the T2 turns out to be mg cos alpha by sine. It is fairly simple to solve questions like this using Lami's theorem. Try to incorporate Lami's theorem whenever you're solving the equilibrium problem. That will take away the burden of writing. Okay. So is the method understood by you guys? Yes or no?
Yes, sir.
So whenever you see the 3/4 or the not kind of problem, always try to apply it. It will always help. So, okay, I mean, there again, questions is with you. What I will say is that go back, take all those questions, solve by the Lamis, and just match the answer and see how powerful the theorem is. Okay, so it will give you the answer in one line. Okay, one small problem we can do. So there is a rough inclined plane, and over the plane we have something like a block. And the forces acting are normal, gravity which acts like downward, vertically downward. And because it is not moving down the plane, so friction is stopping it. And the friction will act up the plane like this. And the block is at rest. We can get the answer of N and Fs by a force component very easily. But can we do it by Lami's theorem? Just for practice. If this is theta, this will be theta. You can check theta 90 minus theta, then theta, right? And this is 90. So what is the Lami's theorem says? N upon sine of what angle?
Angle between F and MG. So that will be
90
90
plus
plus.
theta.
Very good. And Fs upon sine of what angle?
That will be 90 plus 90 minus theta, 180 minus theta.
Yeah. And Mg upon sine of
Sine of 90.
9. Correct. That's the 90 is 9. So sine 90 is 1. So you can see N itself is Mg cos theta if you choose the first and 3, and F is Mg sine theta. So we got the answer, of course, using Lami's theorem. So there is something really interesting about Lamis. When question gets really difficult, then Lamis is a better way than using the component method. If question is pretty much easy, the component will be mostly good for you. So most of the Olympiad level questions can be pretty easily solved using Lamis theorem. So if you know Lamis, it is like a regular question, maybe one line, 1 marks question. If you don't know Lamis, it will become 10 marks question. So that's how physics is either impossible or trivial. There's nothing in between. So if you know the correct method, physics is nothing for you. If you don't know the correct method, it is maybe a nightmare. So what I will say is that go back and practice all those questions that we have done so far using the component method and see the power of Lami's theorem for yourself. So after Lami's theorem, I would like to bring the concept of volume into consideration. So how we define volume? So let's say, let me draw a plane first. So let's say we have two vectors A and B. And if the theta is the angle between them, so we know that A cross B vector will be something like this, normal to the plane, right guys?
Yeah.
So this is the direction of n cap. Okay. All right. Now, if I keep the cross-section area maintained, I can always draw a volume. How to draw the volume? So let's say I bring a third vector which is not in the plane. It is somewhat above the plane like this. This is I will call vector C. So what I'll do next is I'll do some sort of a repetition of sides to create a volume which is very much having maintained cross section, the cross section which is not changing. And we have learned something about the concept of volume today. Not much, but something. So if I call this angle as theta, what is the height of this geometrical shape? I'll tell you the name later on, but what is the height?
C cos theta.
Very good. The height is C cos theta, guys, correct?
Yes, sir.
So can we write H as in vector from C dot n cap?
Yeah.
Tell me, yes or no? Can we write like this? C dot n cap? If you're okay, let me know. C cos theta, of course, H is C cos theta, but it is the projection of C vector along the n cap vector. Yes or no?
Yes.
Yes.
It's a projection of C vector along the n cap vector. And we know how to find the projection. We take the vector and the dot with the direction in which you want to find the projection. So what is the definition of volume? The area of the base, which is mod of A cross B, into vertical height. Can we write like C dot n cap?
Yeah.
Can we write like this, guys? Tell me yes or no. But this can further be written in a very nice way. A cross B n cap dot C. I'm just trying to rearrange the terms. But A cross B n cap is nothing but only A cross B, if you remember.
Yeah.
And now come across something really interesting. A volume is a scalar quantity, and therefore this is called a scalar triple product. And this is called parallelopiped, just like the tilted version of cuboid. Parallelopiped, this entire ball. So it's a three-dimensional parallelogram. You can think this way. It's a three-dimensional parallelogram, which we call parallel pipe. Just like in three-dimensional rectangle becomes cuboid or a cube. This is parallelopipe. So volume of a parallelopipe is written by the triple product. And what kind of triple product is this? Area of the base into vertical height. And to get the vertical height, we have to take the dot. So if I choose A and B as the base, my vertical height came out to be h, which is c cos theta. I can do other way around. I can take a B and C as the base. And if you take B and C as the base, the normal will be like this, or maybe this side. Let's say C cross B is better. So this direction is representing C cross B. Do you realize this? C cross B. And then you can take the projection of A vector on this line. It's the same volume. I can choose any pair of surface as a base, and I can find the height as per the third side left. So what we can say that the volume can be represented in a cyclic order in three possible ways. A cross B dot C, or you can say this is B cross C dot A, or you can also write as A B C, C cross A dot B. The order is very important. You must keep the order intact. The cyclic order A B C. Okay. Because if you reverse the order, the arrow will change and the answer becomes negative from positive. Understood? Anybody getting the idea what I'm saying here?
Yeah.
So our heading was scalar triple product. So A across B, even after the multiplication, remains a vector, because that's called the vector product. And because A cross B is a vector, I can take the dot with another vector, which is C vector. And if A, B, C are not in the same plane, they must have some volume. Now tell me guys, what happens if the C is in the same plane as the B vector and the A vector? The volume will be how much?
Sir, C vector then can be expressed as some formulation of A and B vector if it's in the same plane.
So eventually the volume will collapse. The entire parallel pipe will collapse.
Yeah.
Which means volume becomes zero. Which means volume becomes zero. Do you realize this? Yes or no?
Yes, sir.
So the simple idea is that is the another way of writing the concept of coplanarity of three vectors. If the scalar triple product of three vectors is zero, it means they are coplanar. So if vectors A, B, and C are coplanar, then the triple product must be 0. So this is the another way of writing the condition for coplanarity. Condition for coplanarity. Is this clear, guys, what I'm saying? Now these terms which we have written here, A cross B, and then let me add the third A cross B dot C. So this is generally written in a very nice notation by putting a square bracket and writing the cyclic order A, B, C. The first two will be having the cross and the last will be dot. You can write A cross B dot C, or you can write as C, A, B, or you can also express as A, B, C. And this is the reason it is also called box product. The square bracket is giving the sense of a box. So sometimes it is also called box product. So if you are hearing the term box product, don't get bothered. It's simply another way of writing, which is quite good in appearance. And it will have the same order. The first two terms you will take cross and you will take the dot with the third term. That is the whole idea. In box product, the cyclic order is important. If you change the cyclic order, the sign will come. Of course, the volume cannot be negative, but the mathematical interpretation of negative is the wrong order has been taken. The n cap has reversed the sign. Okay. So in mathematics, although we are able to physically interpret, and because we know the volume is volume, but in mathematics, volume is positive, negative, and zero as well. That's mathematics doesn't take care of what is the physical significance. If it is mathematics, it will have its own abstraction and the meaning. So you have to be careful about the order. A, B, C, B, C, A, C, A, B, B, C, A. The first term was B, C, A. Let me just rectify this. So the geometrical meaning of triple product is volume of a parallel pipe. So I just mention here. Geometrical meaning of box product is volume of parallel pipe. And remember, if the if the C vector is parallel to n cap, it becomes cuboid. Correct? It becomes cuboid. That's the whole idea. And if we have a tetrahedron, then in that case, the answer will become 1/6 of the. Okay, so there is a way of writing. Let me show you one special case for triple product usage. So let's say we have a tetrahedron with a triangular base. And the vertex is somewhere here. So we have a triangular base, let's say A, B, C. And the vertex I'm considering here. And the vertex I will call as O, which is easy to write in terms of writing. It is very convenient. And they say this is called vector A. Just name it. And this is vector B. Assume it. And this is vector C. So of course we can say this is AB vector, this is AC vector. So in case of tetrahedron, the volume you have to remember as 1/6 of AB, you can add across AC. This part. So we'll use the same format as it is parallel pipe. So we can take the base area, which is AB cross AC is the base area. And then we'll take the dot with the height, which we can take as you can take the anyone OA or whatever. This will be N cap. So for AC, AB cross AC, this is N cap, and we want this projection actually. This is the height, and this height you can think as the projection of A onto this line. Okay, that is easy. Yeah, it looks like this. And the same logic we apply. So here A is downward. I'll write AO vector. I'll just keep it AO. Easy for me. Simple. You can take the dot with AO. You are done. And now the question is how to write AB, AC, and AO. So what is AB, guys? AB will be OB minus. I can just write like. Can I write this as B minus A vector? That's easy for us to write. And AC we can write as C minus A. And the AO we can write as minus A. So if you want to remove the minus, you can just change the order. So this minus will change the order here, and then everything will be positive. So you can write as A dot C minus A cross B minus A, and we can keep on expanding this. I mean, it's easy to expand. A dot C cross B. Yeah, fine. C cross B. What else? Minus C cross A. Well, that's fine. Then A cross B. Minus A cross B. And minus A cross A will be 0. So that's it. We can write like this. And A dot this term and A dot this term will be 0, right? Do you realize the answer? Why? Because A dot C cross A. So C cross A is a vector which is normal to A and C both. Oh. You're not able to understand. So all the rest term will vanish. What will left with is A dot C cross B. So basically, Only one triple product is left. A dot B cross C. Okay, but the order is not nice. Okay, A cross C. So B minus A. Okay, fine. Anyway, so this is like some, of course, the order has changed. It's A. You can write like this. You can write like C cross B dot A, which is eventually like a CBA upon 6. So basically, if you take the vertex as the origin, and if you denote the vector for the remaining 3 vertex as A, B, C, the volume of the tetrahedron you can write like this. Okay. A of positive. A is minus. Fine. So this is the answer. You just remember the volume of tetrahedron, and this is something you need to know for some purpose. Like in physics, we hardly use. In maths, only you are going to use this. And the last concept for today will be something called vector triple product. So what is the meaning of A cross B cross C? Now, the first thing that you need to know about the triple product is that this is not same as. So the moment you switch the bracket, the pairing, if you take the A and B first, then if you take C, it is not going to give you the same answer. And that's why there is something called these triple products are non-associative. So we say vector triple product is non-associative. Again, this is the law of mathematics. Like in normal scalar, if I write 5 plus 3 plus 2 or 5 plus 3 plus 2, are we going to get the same answer or different answer?
Same.
Okay, so if you have the addition, then addition is generally associative. Now, if you remove the BODMAS rule, so 5 maybe 10 divided by 5 plus 2 is not equals to 10 divided by 5 plus 2, right? Or are they equal?
Not equal.
So not equal.
So if you use other symbol, then it is again not going to be associative. So there is a problem with the association, like whom you associate will change the answer. In vector, the triple product is non-associative. Generally, the scalar product is associative because it is a volume, so it doesn't matter which two you choose. With third, it is going to give you the same answer. So we said triple product is associative. Sorry, scalar triple product is associative, whereas vector triple product is non-associative. So there is a concept of association. So we have like laws like commutative. Then we have associative, and then there's 3-4 more. Identity, inverse, idempotent, and there are many laws actually. So in mathematics, these are like the fundamental of mathematics on which the maths is built on. Okay, so the Bodmer's rule which you study follows some more intuitive axioms of mathematics to be defined in certain way. And these things we study mostly in masters if you pursue mathematics. Anyway, a basic idea is good enough. So when we solve question in which the triple product is one thing I forgot. Okay, I'll just come to that last. So I'll prove the A cross B cross C part. Okay. So if you have two vectors, let's say B and C, what will be the direction of B cross C? Something like this.
Yeah.
All right. The moment you take the cross with A, what will happen? If you choose any random vector in this space, the moment you take the cross again, it will come back to the plane of B and C. Do you realize this? Like no matter where the A is, let me do it. If I call this as A vector, so A cross B cross C, what will happen? This is going to be the normal to the plane of B and C and this vector and this vector, like something like this. And if this new vector is normal to this line, can we say this is in the same plane as B and C? Can we say yes or no?
Yes, sir.
So this entire vector is actually in the plane of B and C. Therefore, the rule says that A cross, the vector which you associate will decide the plane of the entire vector. So A cross B cross C must be in the plane of association. And what is the association here? B and C. Understood? So A cross B cross C is always in the plane of B and C. That's a thumb rule to remember. The association will decide the eventual plane. That is why if I write A cross B cross C, which plane it will take? Eventually, this entire vector will be in which plane, guys?
The plane of A and B.
Plane of A and B. Okay. So lies in plane of A and B. Lies in plane of B and C. So the association is very important. Like to whom you associate will eventually decide the plane in which the entire triple product will lie at. So if I write A cross B cross C, and because it will lie in the plane of B and C, we have studied something before that any vector in the plane of B and C can be written as some X times B or some Y times C. Can we write like this? Yes or no?
Yes, sir.
So this must be equal to something like this: X times B and Y times C. Okay. So let's call this as P vector, which is X times B plus Y times C. So what is the P cross A vector or A cross P? I like A cross P. No, not cross. I will take dot. So what is the P dot A vector? P dot A. Now P is in the plane of B and C. So P dot A will be how much, guys? Tell me. You can just multiply both sides. P dot A will be B dot A, or you can say A dot B, plus Y times C dot A. Just like that, you can write like this. So P dot A we can write as X into B dot A plus Y into C dot A. No, I should take B. Just one. So P dot A, you can write like X into B dot A plus Y into C dot A. Just write this clearly. Okay, so P is in the plane and P dot A. So what do you think the P dot A will be? P dot A in the plane. Can we say P dot A is 0? Yes or no? If you take P as this, then P and A are mutually perpendicular, no? Because P is representing what? A cross B cross C. This is the P vector, right?
Yes, sir.
So this vector is going to be normal to A and this entire term, B cross C, whatever. You can, if you want to connect as A cross D vector, where D is B cross C. Just one. Sorry guys, got a problem. So the P vector and the A vector is going to be perpendicular. So this term will be how much? 0, because the dot of P and A will give you 0. And therefore this equation will give you something. What will give you? Sure. X into B dot A plus Y into C dot A is 0. So I can write something like this. This is written in this way. So X into B dot A equals to Y into C dot A. And therefore you can write as X upon C dot A. You can write as minus Y upon B dot A. You can write like this, something in a ratio. And then you can assume this as, let's say, K. This is ratio is K. So our answer A cross B cross C, which we are trying to find, which is XB plus YC. The X can be replaced by K times C dot A into B plus, and Y is how much? Y is minus K times B dot A into C, which you can rewrite as K common, and it is C dot A, or I can say A dot C, that's better way of writing. A dot C into B vector minus, and it is A dot B into C vector. This is the answer. But what is left here is the K is extra value which we need to determine. So now there is one more step to get the K value. So how to get the K value? So for K value, we do a small trick. We can assume, let's say, A as I cap. You can take C as I cap and take B as J cap. Just take any random set of values, because this is easy to, take a cross and dot. So I am taking A and C as I and I, so that I can get a non-zero term. And then A dot B becomes automatically 0. So now substitute here in this expression. So LHS will give you what? I cross J cross I. What is this value? Tell me. J cross I is how much? Minus K. And I cross minus K is same as K cross I. And what is the K cross I value? Tell me. K cross I. Can we write J cap?
Yes, sir.
Oh. And RHS is how much? Do the same thing here. A dot C, which is 1. I dot I is 1. And B is J. So this is J cap minus A dot B is 0. That's gone. So what we're getting is KJ. LHS is J and RHS is KJ. What does it mean? K is how much? If you compare the LHS and RHS, what you will get? So LHS, if you compare with RHS, you can see we have on the LHS is J cap and RHS KJ cap. So can we say K equals to 1?
Yes.
And therefore, the A cross B cross C becomes A dot C into B vector minus A dot B into C vector. And now this is easy to remember. How we remember? Outer dot minus inner dot. A dot C, the outer, A dot B, the inner, and the term which is left, we write here. A dot C means B is left, and A dot B means C is left. So this is how you generally remember the triple product of vectors. And probably there is no geometrical meaning which is known to me. It may have some meaning, but I don't know. I never explored this part. What is the geometrical meaning of this? So you can remember this is A dot C into B minus A dot B into C. This is how we can convert a triple product into a simpler term like this. Okay, what else was left? Yeah. So the box product so the box product we can write as IJK and sorry, not IJK. So if you remember the B cross C, it is A dot B cross C. So how we write B cross C? Let me just show you like this. A cross, sorry, A dot B cross C. You can write as AX I cap plus AZ K cap, and the dot I have to take with the matrices of B and C, which is IJK BX BY BZ CX CY CZ. And when you take a dot, then I will go here, I with I, J with J, and K with K. And interestingly, this will become actually AX AY AZ BX BY BZ and CX CY CZ. So the box product we can simply write as a determinant of all three vectors. If you want some rigorous proof, you can expand this term, and then I will vanish, AX will come, J will vanish, AY will come, K will vanish, AZ will come, and you can rewrite like this. So this is also the volume formula. The volume of parallelopipe formed by vectors A, B, and C. And if they are coplanar, then this determinant will be 0. So you can simply put forth like this. So if A, B, and C are coplanar, then if A, B, and C are coplanar, then what we can say? The mod of AX, AY, AZ, BX, BY, BZ, CX, CY, CZ is equals to 0. Okay. So I think we have done with the vector chapter. Of course, there's no end to it. You can keep on exploring, keep on learning something more. But every assignment which I have shared now, you can solve every assignment. Try to finish everything. And the next lecture, I will first start with the doubt session. And your next lecture is on what? Friday, right? So Friday, you won't have any lecture. This week, no lecture. Now we'll start again from the next week only. So you have entire time of more than 1 week. And I hope in that time you can finish everything. Okay. So try to finish as much as possible. I hope, I may share some more questions. And then we'll start the two parallel concept. I'll start. One day I will keep mathematical tools. And the other day I will keep maybe kinematics or laws of motion. Whatever I think at that moment I'll choose. So bye guys, take care. And do finish all the assignments. See you in the next lecture.
Yes, sir. Thank you, sir.
Sir.